Okay, so today we are just going to start our topic, that is chemical bonds. Previously, we already have discussed atoms, their structures, their electronic configurations, how these atoms are able to make different bonds with each other. Today, we are just going to be emphasize on these things, like how they are able to make different bonds. We already have discussed about their electronic configuration, number of electrons they are having, and how they can get stability today in this lecture and in further more onward all the, your lectures. We will discuss that how they are able to make different bonds. What is basically with a chemical bond? There are different types of chemical bond is basically the force of attraction, you can say. This is a force of attraction which holds different atoms together. Got it? Next is firstly we will just uh, discuss that which will things we are just going to cover today. Firstly, we understand the ion, what basically they are, what is the basic definition, types and formation of different ions. We will discuss here that what is cations and anions. We will already also discuss their. So next, we will discuss the octet rule. What is the octet rule? Basically, eight number of electrons they must have in their outermost shell. And what is the secret behind the atomic stability? We will discuss it about it, and how they are able to get their noble gas configurations. Next, we will discuss that how we people can write the ionic formulas for them, how their ions are formed, what will be their ionic formula, and after making different ions, how they are able to make the bond over there. Then how we will know that what the charge that ion will have, how we can predict it. We will also discuss it in this lesson. Then we will learn about the electron transfer diagrams, and certainly we will just do some sort of different questions which are given in your books as well. So moving quickly towards your first topic, that is what are ions beta. So firstly, its definition, we will just focus on it. An ion is a particle with a positive or negative charge. So it is formed when an atom either gains or loses one or more electrons. Fine. So ion is a particle with a positive or a negative charge. Basically, it's an atom, and when that atom gains an electron, so it means that it is having one more electron in it. So it's having a negative charge. When an atom loses an electron, it means it is removing one negative charge, because electrons are having negative charges. It is removing one negative charge, so it has one positive charge more. So the ions which are having positive charges are known as cations, while the ions which are having negative charges are known as anions. So moving towards cations, positive ion forms when an atom loses electron. When an atom is loses electron, like we already have discussed the example of sodium in your classes as well. So sodium, what is the sorry, atomic number of sodium? You all must have your periodic tables with you, bete, like right now even. So what is the atomic number of sodium? Any one of you can please tell me. And so when we just okay, fine. When we just arranged all these electrons, 11 atomic number means they are 11 electrons. Sodium has 11 electrons in its outer in their shells. Fine. So when we are just arranging these electrons, so in the first shell, that is K, there will be two electrons. Then we will move towards the next shell, that is L. We also have to place 8 electron over there. One electron is left, which will move towards the third shell. So what will have to sodium? Sodium will do. Sodium will just lose that one electron. So by losing one electron, it is having a positive one charge. Similarly, we already have discussed the chlorine's example in your live classes, face-to-face classes as well. Anions, when they are gaining an electron. Anions formed or the negative ion forms when an atom gains electron. What is the atomic number of chlorine, beta? Only a single student will tell me. 17. What is, sorry, it's 17. So you people will have to arrange it. Like in first shell, there will be two electrons. Next one will also have eight electron. And in the third shell, there will be seven electrons left. Now it is having a deficiency of only one electron, which it can take from sodium. So by taking that electron or gaining that electron, it is having a negative charge and forms an anion with the formula Cl negative. Got it? So you just have to keep in your mind the charge rule. Loses electron means more protons than neutrons, and the atom will have a positive charge. When you are gaining an electron means now your atom is having more electrons than protons, so the negative charge will be over there. Gaining electron is equals to negative charge and losing electron is equals to positive charges. Next is octet rule. Now, what is the term octet rule? Atoms tend to gain, lose, or share electrons to achieve a full outer shell of electrons, just like noble gases. Now, firstly, we will discuss here the noble gases. We will take the example of neon. What is the atomic number of neon? 10. So when we arrange when we arrange the electrons of neon, that is 10. So in first shell, 2 will go, and in the second, 8 will be. So the second shell is almost complete. Next example, you already have on your screens, that is argon. Its atomic number is beta 18. So its electronic configuration is 288. What does it mean? In the first shell, K is having 2 electron, L will have 8, and M is also having 8 electrons. So 8 electrons in the outermost shell makes that element, makes that atom stable. So elements or atoms having 8 electrons in their outermost shell to get stability, this is basically the octet rule. Why 8 electrons? This configuration has the lowest energy and the highest stability in the nature. Is there any confusion? Fine. Next is making stable ion like Na positive. I already have discussed on your previous slide like how sodium is having 11 electrons. In its outermost shell, there is only one electron. So when it loses it, it gets stability because now its outermost shell is having only 8 electrons, which is stable. Similarly, chlorine, after gaining one electron, it can get stability because now 8 electrons in its outermost shell, which denotes it's a stable. Is it clear? Now, how we are able to write an ion formula? How we are able to writing an ion formulas, and there are some rules and examples I am going to discuss with you. First of all, writing rules. What is the writing rule for ionic formula? Positive charges, fine, or what will be their position, positive or on the negative charges, fine. Position of charges. We just have to write positive or the negative sign on the right of the chemical symbol. Now you can see different chemical symbols on your screens like potassium ion, magnesium ion, bromide ion. Fine. So all these elements are having the are having the positive or negative charges on the right side of their chemical symbols. Is it clear? And now, what is the subscript format? Write the charge as a subscript. Is the meaning of what is the meaning of the subscript? Subscript means that you must have to write that above the line. You must have to write that charge above the line on the top of the like K potassium ion K positive. What does it mean? I already have told you when there is only one uh, removal of electron or gaining of electron, gaining or losing of one electron, then we are not going to write one with it. Only positive already means it's there is only the charge is positive one, and only negative charge means there is the charge negative one. But when there are more than one electrons which are moving into the atom or out of the atom, like gaining or losing of electrons, more than one or two, one or gaining or losing of electron, then we must have to write the number with it. Fine. So if there is number, then we just write the chemical symbol. For writing chemical symbol, I'm just revising that thing. If there is only one letter, it must be capital. If there are two letters for the chemical symbol, we write the first letter capital and the second will be small. Like in potassium, only single letter is there, so it is capital. While in magnesium and bromine, two letters are there in their chemical symbol. So first is capital M and B, and second will be small, that is G and R. Then comes the charge. Now, what is the charge? If there are only one electron which is moving, so no need to write the number. But we will just write only symbol, positive or negative. While if there is more than one electron, then we just write, firstly, we have to write the number of electrons, then we will write positive or negative charges. Got it? Now we will just move towards the table which I have given to you in the lower part. It is sodium. Its chemical symbol is Na. And how many electron it is going to be lose? One. When it is losing one electron, so ionic formula will be Na positive. And what will be its charge? It's positive, 1. For chlorine, is gaining one electron, so its ion formula will be Cl negative. And what will be its charge? Negative 1. For magnesium, it is losing two electrons, bete, and its ionic formula is Mg2 positive. And what is its charge? It's positive 2. Next, we will just discuss how we are able to predict the ion charge. What charge will be there on that ion? Okay. Now we are just be focusing on the example. Predict the charge on the fluorine ion. Explain your prediction with reasoning as well. So step by step, I'm going to explain it. Firstly, we have to analyze the atom. Fine. Fluorine has atomic number 9. Firstly, we will move towards the periodic table. Go there, check what is the atomic number. What is the atomic number? Yes, please check. Any one of you can tell me what is the atomic number of fluorine on your periodic tables? It's 9. Got it? After getting the atomic number from your periodic table, next step, you just have to do the electronic configuration. 9 will be divided as 2 and 7. In the first shell, there will be 2 electrons, and in the second, there will be 7 electrons. Means 7 electron in the outermost shell. Is it clear to all of you? Fine. Now, what is our goal? What we just want to do with that atom? To become stable, it needs a full outer shell of electrons. While it is having 7 electrons, why? According to the octet rule that we already have read, outermost shell must be complete with 8 electrons. Fine. So, what we have to do? Easier to gain 1 electron or to lose 7 electrons? What do you think? Fluorine is having 7 electron in its outermost. Yes. It's easy to gain 1 electron from the other from any other source. So after gaining 1 electron, it can get the octet rule. It can be get stable. So with this, according to this situation, you can calculate the charge. Now, if it is gaining 1 electron, so what charge it will be having? If it is gaining 1 electron, negative. If it is gaining 1 electron, then it is negative 1. Fine. But when it is predicted charge, it is negative 1. But if there is 1, so no need to write this, we just write it F negative. So since electrons are negatively charged, so gaining 1 electron means minus 1 charge. Is there any confusion in this thing, Bete? Are you able to predict any ionic charge for any element? Next is the electron transfer diagram. This is a very important topic as well. Here we are going to take the example of dot and dot. Yes. Okay, I'm trying my best. Maybe there is some sort of internet issue, so it's not clear. Electron transfer diagram. Here we are having the example of sodium and fluorine beta. So we already have predict the sodium charge. What it can be? Sodium's firstly we will move towards its atomic number. Sodium atom's configuration is 2, 8, and 9. Fine. It is having one electron in its outermost shell. While fluorine atom atomic number is 9, its configuration is 2 and 7. It means 7 electrons in the outermost shell. So from this information, we are able to predict that what thing we can predict. Any one of you, please, beta, anyone, only one student from you, not all of the you students start speaking. Tell me that what will happen over there right now. Any one of you can answer because I'm not able to see your raising hands. Which will lose one electron? Sodium, because it is having only one electron, so most probably it will lose that electron, and fluorine has a tendency to gain that electron. So what is the third step? The third step over there is electron move from sodium to fluorine. Got it? And what will be the result? Both achieve now 8 electron in their outermost shell. After removing one electron, this shell will remove from the sodium, and fluorine will get 8 electron after gaining that. Is this thing clear to all of you? Next is before before reaction, you what will be the diagram, or what will be the situation for sodium and chlorine? Then transferring of electron is over there from sodium to chlorine. It is going to be transfer. Fine. So before reaction, sodium has 11 protons, 11 electrons, and it is having no charge. Its electronic configuration is 2, 8, and 1. After losing one electron from the last cell, it is from the last shell, it is its protons will remain same, that is 11, while electron number of electron reduced from 11 to 10. Fine. And now its configuration is 2 and 8, that is